Hey guys, it's Eddie the Magic Monk. Welcome to another maths lesson. Here is a problem solving question that involves using calculus to find the equation of a tangent by differentiating. So hopefully you enjoy this question, have a go at it. If you can't understand it, I'm gonna give you guys a bit of a hint. So the first part of the question says that a bird's eye view of the path of a discus as an athlete swings it is described by the equation y equals negative 0.7x squared plus 1.4x with a domain of of x being between 0 and 0.75. So what does that mean? So I'm just going to draw this curve and then I will explain it to you. So this is the curve, y equals negative 0.7x squared plus 1.4x. Now the question also adds that this curve has a domain restriction of 0 to 0.75. So putting that in, the curve now only goes from 0 to 0.75. So this is the path of the discus. So if you imagine a person swinging it around, so the person might be standing here and this is their arm throwing it around, swinging it around. This is a bird's eye view looking down at the person. Okay, so let's go back to the question. So the next part of the question says that when the discus is at 0.75, so when that first line ends, the athlete throws the discus tangentially on a straight line. So what does that mean? So what it means is when x is equal to 0.75, so when this red line ends, basically, whatever the gradient is at this point, the line is going to keep going at a straight line from this point. So the tangent line that is just touching this point, which is modeled by this equation here. Okay, I'm just going to set a domain of 0.75 onwards so you can see it better. So the purple line is the tangent to the red line at x equals 0.75, and basically it's the path of the discus after it is thrown, so it keeps traveling in this direction. And then what does the question say? If the discus lands at x equals 20, will it intersect with the boundary line, which is described by the equation y equals 0.3x plus 1.25 before landing? So when the discus is moving along the purple line, it's going to keep going until x is equal to 20. So this point here, when x is equal to 20, is where the discus is going to land. Now, will the discus intersect with the boundary line before it lands? Now the boundary line is described by the equation y equals 0.3x plus 1.25. So it's described by this black line is the equation. Now, does the purple line touch the black line? So instead of using graphs, let's just work it all out algebraically so we know for sure whether the discus is going to touch a boundary. So the first thing we're going to do is find the equation of the tangent. So if y is equal to negative 0.7x squared plus 1.4x, then y dash, which is the gradient of y, the gradient function of y, is going to equal negative, so 2 times 0.7 is 1.4 x plus 1.4. So that's the function that's going to give you the gradient of this line. So what is the gradient at x is equal to 0.75? So we're going to substitute that in. All right, the gradient of tangent at x equals 0.75. So we're going to substitute that into the gradient function. So y dash equals negative 1.4 times 0.75 plus 1.4. So let's type that into the calculator. Negative 1.4 times 0.75 plus 1.4. And the answer is 0.35. So that is the gradient of our tangent equation. So the tangent equation has the form of a straight line, y equals mx plus c. Right, that is the gradient, that is the equation of a straight line. So we've just found the gradient. So y equals 0.35 x plus c. So we just need to find c now for us to get the tangent equation. So in order to find c, we need to know the x and the y coordinate where the tangent line is touching the graph. So we're going to substitute in the x and the y coordinate. So the x coordinate is 0.75. We don't know what the y coordinate is, so we've got to find that. So y equals, you're going to substitute x into the original equation to help you find the y coordinate. So y equals negative 0.7 times 0.75 squared plus 1.4 times 0.75. So let's put all that into the calculator. 0.65625. So that's the y coordinate. So what we're going to do is put that 0.65625 where y is. So 0.65625 equals 0.35 times x coordinate is 0.75, and we want to find out what c is. So let's rearrange that. C is equal to 0.65625 minus this whole section here, so minus 0.35 times 0.75, and the answer is 0.39375. So that is the equation of the tangent line. Y equals 0.35x plus 0.39375. So now that we have the tangent equation, I'm just going to find the intersection between the tangent line, which is this line here, the tangent line, and the line of the boundary, and see where they intersect. So I'm going to put in 0.35x plus 0.39375. So that's my path of the discus, and I'm going to make that equal to the boundary line, which is 0.3x plus 1.25. Right, and if I make two lines equal to each other, I can find out where they intersect. Okay, so what I'm going to do now is I'm going to solve it. So I'm going to move all the x's to the left. 0.35x minus 0.3x. I'm going to move all the numbers to the right. So 1.25 minus 0.39375. And then the left-hand side will become 0.05x. And the right-hand side, let me type that into the calculator. 1.25 minus 0.39375 will be 0.05 85625, and x is equal to, so divide that by 0.05, 17.125. So the two lines will intersect at 17.125. So let's bring the GeoGebra back up and see if that is the case. So again, you can see that the red section here is the path of the ball, the disc is before it's thrown. The orange line is after it's thrown. It keeps traveling. The black line is the boundary. So the orange line intersects the boundary at x is equal to 17.13. So yes, they do intersect. The answer is yes, they intersect before. Yes, the discus intersects the boundary before x equals 20. Okay, I hope this question wasn't too confusing for you guys. Thanks for watching. See you next time.